Hello. Today we're going to be working with torque and forces, and we have this right here, this crane right here. It's at an angle of the beam is at an angle of 30 degrees, lifting up at 60 kilogram, and they give us the tension, and they give us this degree. They tell us that the beam is 1,000 newtons. This case right here is 784 newtons. They want us to find the tension, the force Hx, and the force Hy. First, we need to identify our forces and our torque. We know that we have, this is our pivot point right here, and we have our x direction, and we also have our y component. Our y component. And we want to write this right here, f h of y, and this right here is going to be our f h of x, right? And they also tell us that right here, the angle that this makes right here is 30. So the first thing that we want to find is, I know that we have a weight right here pushing down, right? And we also have from the center right here, from the center right here, we have also a force pushing down. We also have a force pushing direction right here. That is our tension right here. This force right here is mgc, and this one right here is mg beam, the beam. You know that beam is 1,000 newtons. So now we have our 1, 2, 3, 4, and 5 forces acting right here. We need to find our torque now. And we know that the torque, right here, center right here, we know that the torque is going to be equal to the force, right? The force perpendicular to the radius, right? The force perpendicular to the radius. And we know that here, right here, if this is 30 degrees, this is also 30. And right here, find the force perpendicular, and we know also that this is 30 degrees, okay? So we have forces, and it also is perpendicular to the radius. And this is the radius right here for this one, and this is the radius for the longer beam. So now, what we need to know is, I remember that any movement clockwise, I describe it as negative, and counterclockwise, I describe it as positive. So now, I need to find this component right here. And I know that this component right here has got to be perpendicular to that right there. This is my 90 degrees right here, and we're going to come over here because we need to find what this angle is. This is my tension right here. So if I want to find this angle, all I will have to find is find the perpendicular. And if this is 60, this is 30. This is 30, this is 60 degrees. This is 30 degrees. So this right here must be 50 degrees. And these are my right angles right here. So this will be then 30 and 50. This will be equal to 80 degrees. So now I can go ahead and do all of my components of the forces and all of that. So I know that the torque net must be equal to 0, and that the sum of our torque must be equal to 0, and the torque is equal to the force perpendicular to the radius. And we have 5 forces and 3 torques. So what we need to do is we can go ahead and set the sum of all torque must be equal to 0, And I know that for this component right here, it's going to be equal to, right, mgv times the cosine of 30 degrees times, it's in the middle of the beam, L over 2. So this is going to be, and it's going to be negative because it's pulling down, negative mgb cosine 30 degrees times L over 2 minus the other one is going to be the same thing. It's this one right here, which is going to be mgc times the cosine of 30 degrees times the length of the beam. Plus, I just find out my component is perpendicular, so it will be the sine. It will be t plus t sine of 80 degrees times the length. And now if I move everything to the side, t sine 80 degrees is equal to, and I know I have a negative, but once I move it to this side, it'll make all of this positive right here. It'll be mgb cosine 30 degrees. And right away I know also something. I can get rid of the L, my length. I can get rid of all of this L right here, and right here. Sine of 30 degrees plus mg of the crate cosine 30 degrees, and this is over 2, I'm sorry. So I'm going to have to multiply this by times 1/2. And once I do that, I could get the sine 80 degree, move it to the bottom, and I get that this will be 1/2 times 1,000 newtons times 0.866, which is cosine of 30 degrees, plus 784 newtons times the cosine of 30 degrees, which is 0.866, and all of this divided over sine of 80 degrees, and sine of 80 degrees, I don't remember what it is now. Sine of 80 degrees, and your tension will be equals to 1,129 newtons. So we just found right here the tension, 1,129 newtons. And now what we need to do, we're going to write our, so we could find these two forces right here, our X and our Y are here, and we need to know that the forces acting on the X is 0, and right here is FH of X, and the forces acting on the Y right here is 0. This will be FH of Y, and I know that in the X it will be 0, 0. This will be right here negative mgb negative mgc, and our tension is going to be pulling on this direction. So going to be pulling on this direction right here. We have tension pulling on this direction. So this will be negative T sine of 50 degrees, right? Because we have it over here, 50 degrees, plus T sine of 50 degrees. If we get to what I'm going to do is I'm going to stop now, and I'm gonna continue in another video. I don't have enough time. If you like this video, please hit like and subscribe. Thank you.